Okay, I will explain some of the theorems that are related to the circle. Okay, listen very carefully. So the first theorem is that in a circle, if you take two arcs AB and CD to be equal, the angles subtended by these equal arcs are going to be equal at the center. So AB and CD, they are equal. So the angles subtended here at the center, they are also equal. That means if AB is 5 centimeter and CD is also 5 centimeter, let's say, angles subtended by them at the center is also, they are also going to be equal. Let's say this is, if this is 30 degree, this is also going to be 30 degree. Okay, let's move on to the second. Similarly, if the arcs are equal, here I'm taking two arcs AB and CD to be equal, the angle subtended by these arcs at the circumference now. It was at the center, now at the circumference. They are also going to be equal. Okay? And then third, let's move on to the third. If you have two arcs MN and OP, equal arcs in the same circle, the length is equal, MN and OP, they are equal. The distance from the center, distance means perpendicular. The perpendicular distance from the center, they are also going to be equal. This OX equals to OY. Okay. Now the converse is also true. Converse means, so if I take two chords at the same distance, I'm taking XY chord and MN chord, okay, at the same distance. I don't know the length, but I know that they are at the same distance. That means OQ is the distance of XY and OP is the distance from the center of MN. Consequently, what happens is MN, the length of MN is equal to XY. That's a beautiful result, okay? And similarly, I have another result here. Result number 4. If I draw a perpendicular from the center on a chord MN, the line, the perpendicular actually bisects the chord. That means it makes it into two equal halves. So MP is equal to PN. So it's made by this perpendicular line, which is from the center OP. And the converse is also true, the opposite. That is to say, if I have two, if I have a line from center OP that bisects a chord here, MN is the chord. That is to say, MP and PN, they are both equal. The length of MP and PN are equal. Consequently, what happens is this OP forms a perpendicular angle. That is to say, OP will be perpendicular to M. That is the converse of what we did just now. And the fifth one, which is quite famous in geometry, is that an arc PQ, if it forms an angle at the center, and similarly the same arc or any other arc of the same length forms of the same circle forms an angle at the circumference, like here you see at the circumference, this is the angle. So the arc of this angle, arc kun hota, it's PQ. And similarly, what's the arc of this angle? PQ. So both of them have the same arc, or it can be same, arc of similar lengths, of same length. Here there is a relation, beautiful relation. The angle is going to be double. The angle at the center is going to be double of the angle at the circumference. Here also similarly, even though the arcs are not the same, but they have the same length in the same circle. So therefore, this angle is going to be half of this angle. Okay, both of them actually represent that thing. And then if you have a quadrilateral inside the circle, which is called a cyclic quadrilateral, here PQRS, that means the vertex of the quadrilateral P, another vertex Q, R and S, they lie on the circumference. Okay, if that happens, then if you, it's another letter. If you find the sum of the opposite angles, surprisingly what happens is they are supplementary. That means they sum to 180 degrees. Angle P and angle R, if you sum them, it gives you 180. Similarly, if you sum S and R, S and Q, it's going to give you 180. Okay. And the seventh one is also another beautiful one. So here what happens is, if you have a tangent, what is a tangent? Tangent is a line that touches at one point and passes by touching one point of the circle, and it does not cross the circle. Okay, that's a tangent. So if you draw a line from the center on the point of contact, the point at which this tangent touches, that's called the point of contact, right? What happens is it forms 90 degree. It forms a perpendicular and it becomes perpendicular to the tangent. This is another very interesting result. And then I have another interesting result here about tangent, result number 8. So if you have an external point R and if you draw tangents, you can only draw two tangents on the circle from an external point. One is this one and the other one is this one. You take another point, you can draw two tangents. Interestingly, what happens is the distance from that external point to the point of contact, you have 2 points of contact, right, where the tangent touches. These tangents that touch, the lengths are going to be equal. That is to say, PR, the length of PR is going to be equal to PQ. RQ. So, okay. And the last result here is a bit of a challenge to understand maybe, but it's easy. So you have a tangent here, this one. It touches at point R. R ma touch gareko cha. And then you have a chord here. QR is the chord, and it forms this angle QRS. Okay, this angle will be equal to the opposite angle of this chord. That is to say, QR opposite is this one right here in this triangle. So this angle QPR. So this angle is going to be equal to this one. Similarly, if you take this angle, so here PR is the chord and the tangent is TS. So that's the angle between this chord and the tangent. So the angle opposite to this side is Q. They are going to be equal. So these are some results of circles that are very interesting. So you can explore more. So we are exploring here. Okay. Thank you. Bahasa apa sih dia? Yes.